Hi, hello, this is Dr. Swapna welcoming you to your Learn Lab, your one-stop for learning. So in this video, we'll be learning the computation part of Kruskal-Wallis ANOVA. We have already studied the theory part. In case you haven't watched the video, just go back and you can watch it. I'll add the link to the description. So without wasting much time, let's just dive into the topic. So the question we have is from TEE June 2024. Okay, so there's a fun thing. I went through past 6 TEs and this was the only question that ever came from this topic. And because this was June 2024, which is last year, I decided to have this video also because you never know what you will be getting. So in the theory part, I've told you that Kruskal-Wallis ANOVA is an extension of Mann-Whitney U test. So the choice will always be between Mann-Whitney or Kruskal-Wallis. One of the topics you will get. So maybe you can prepare both of this so that you won't be caught off guard with the question. So the question here says, what is Kruskal-Wallis ANOVA test? Compute the Kruskal-Wallis ANOVA for the following data. And the mark distribution is 3 plus 7. So 3 marks for the theory and 7 marks for the computation. Theory part I have already taught you in the previous video. So let's move ahead with the computation part. What do we have here? We have a table with 3 groups, group A, group B and group C, and we have 5 values under each group. So again, I told you that this is an extension of Mann-Whitney U test. So most of the steps, the first few steps at least, are exactly same as what you did for Mann-Whitney U test. And do you remember what those were? Okay, we'll go forward. The first step is formulating the null hypothesis and alternative hypothesis. What is the null hypothesis? That there is no significant difference between two sample medians. And what is the alternate hypothesis? That there is a significant difference between the two sample medians. And this first step is something that is going to be the same exactly, irrespective of what the data says or what the question says. So if you get a question on Kruskal-Wallis, you can just write down this as the first step. What is the next step? What was the next step that we did for Mann-Whitney? We arrange the data in ascending order. So if you remember, this was our original data. And if you take a closer look at this, it's all just 2s and 3s. We have lots of 2s and lots of 3s. So let's just go and arrange this in ascending order. So if the question comes like this, it's going to be really easy, right? There's no other number, just 2 and 3. You just have to count all the 2s, write it, follow it by 3. I have done exactly the same here. I have all the 2s and all the 3s here. So when you have numbers repeating, do you remember how we have to calculate the ranks? We first assign what? We first assign the serial numbers. Let's assign serial numbers. I have assigned the serial number. So we have in total 12 2s and 3 3s. So to calculate the rank for all the 2s, what are we supposed to do? We have to take the average of these serial numbers. And how do we do that? We add all these up. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12, all divided by the total number of observations. This is 12. I've already done this here for you and my answer is 6.5. You can try calculating this yourself. Okay. So the remaining values, I have 3 3s here. I'm going to take the average of 13, 14 and 15, which is 13 plus 14 plus 15 divided by 3, which is 14. So I have all the ranks here. Now I'm going to put all these ranks in a separate table. So yeah, I have all the ranks and all the tables intact here. So after we have this, do you remember what we have to do? Yeah, we have to add all the ranks. Before that, we are first going to put all the ranks back to the original table in question. So we make a new table. We add columns next to each of the groups. So after group A, I have a column for the rank A. After group B, I have a column for the ranks of the B values. And after group C, I have another column for RC. So you can make this table and we'll fill in the ranks. Okay, so after filling in the ranks, the next step is we have to add up all the ranks. We have to calculate RA, write it here, RB, write it here, RC, write it here. I have the totals here. My RA is equal to 40. Sum of RA is 40. My sum of RB is 32.5 and my sum of RC is 47.5. So we have all the ranks. Now we go and calculate the Kruskal-Wallis ANOVA statistic. So till this step, all the steps are going to be exactly same as how we did for Mann-Whitney U test. And after this step, both are going to change. In Mann-Whitney U test, you calculated U and U dash. Here we are going to calculate the Kruskal-Wallis ANOVA statistic, which is called the H statistic. Here I have my formula for the H statistic. It says 12 divided by n into n plus 1 within a big bracket sum of ri square by ni minus 3 into n plus 1, and you can close the bracket. Here n is the total number of cases, which in our case is 15. How? We have 3 groups and 5 values under each group. And Ri is the individual rank, sum of the ranks. Like we had calculated RA, right? We have calculated RB and we have calculated RC. What is NI? NI is the number of cases in each group, which in our case is 5. Okay, so we have all the values with us. Let's just put the values and see what we get. So we'll substitute the values. I'll just repeat the formula. H is equal to 12 upon n into n plus 1, and then within big brackets sum of ri square by ni minus 3 into n plus 1. So let's substitute. This becomes 12 upon 15 into 15 plus 1. Sum of ri square by ni. This is, we have to add up all the ri square by ni square. So in this case we have ra square by na. This is the total number of ranks squared by total number of observations in group A plus rb squared by nb plus rc square by nc. So substituting the values here, we have 12 by 15 into 15 plus 1 into 40 square by 5 plus 32.5 square by 5 and 47.5 square by 5. So this was our sum of RA, this was our sum of RB, and this was our sum of RC. And this is the total number of values in each group minus 3 into 15 plus 1. So I have calculated here and I have got this value 1.125. So if you get this value correctly, you have your 7 marks with you. Next we have interpretation of the result. Interpretation of the H value. So you can write this down in your paper also if you want. You can write that. Find the critical value from Kruskal-Wallis table for k is equal to 3 and sample value of 555. Even though in the examination you will not be given any table, this is just for writing purpose. If the critical table value is higher than the calculated H value, null hypothesis is accepted in this case. And if the critical table value is lower than the calculated H value, the null hypothesis is rejected. So this is all that you need to do for this question. I didn't get any other PYQs because this was a one-off kind of question that came. But since it came pretty recently, I thought I'll include this. But you can go back and find more questions that you can solve, probably from the study material or any other sources. I have links here in case you want to check if your answers are correct. I'll add these links to the description also. So I hope that was easy. If you remember the Mann-Whitney U test, you can just remember that for Kruskal-Wallis also the steps are going to be pretty similar. Only the final formula is a bit kind of difficult thing for you to mug up. And there is no other choice other than mugging up also in here. So that was all in this video. Use the like, subscribe and share button as you feel right. Keep learning and take care. Stay with me. Bye-bye.